All right, hi everybody. Thanks for having me. It's really a great opportunity to speak here, and academia is one of my favorite parts of this industry, so this is a highlight of my week. Thank you. So I am CEO of a company called World Buildr, and we do something called digital twins. So let's start with, what is a digital twin? Well, if you've seen the movie Avatar and you've seen the scene where they're all sort of congregated around that holographic table looking for the unobtainium deposits, that is a digital twin. If you watch the show Westworld on HBO and you see that command room where they're looking at the gameplay area and talking about all of the different players and strategies, that is a digital twin. And even if you've seen the Iron Man movies and you've seen Tony Stark building his suit and disassembling it virtually and reconstructing it, that is also a digital twin. But digital twins are real in the real world. Well, they're digital in the real world. I mean, they really exist is what I'm trying to say. And they allow us to ask the question, or to answer the question, what if we could predict failure? And this becomes a very, very valuable tool in our process. Digital twins, just to sort of go into a little bit more definition, they're more than just 3D models. They are 3D models with integrated systems. So a digital twin is not just a 3D model of a heart. It is a 3D model of a heart that includes the circulatory system. And you can see the actual machine moving and the blood flowing and pumping. So you can actually analyze what's happening within the heart. A digital twin is not just a 3D model of a car. It is a simulation of the aerodynamics of the car and the fuel efficiency of the car and things like that. And a digital twin is not just a static model of a factory, but it is a dynamic model of a factory that you can use to study an assembly line and see where you can get these operational efficiencies and immediately recognize it visually. And one of the things we've been doing at World Buildr is we've partnered with Unity Technologies, the game engine, and this is actually language from Unity themselves. They have different levels of digital twins. There is the virtual twin, the connected twin that is tied into real-world sensors. And then there is the predictive twin, which leverages data to predict outcomes. The next level is the level 4 prescriptive twin, which leverages advanced modeling and real-time simulation for future scenarios, as well as prescriptive analytics and recommendations. And then the final level is the autonomous twin, which is both predictive and prescriptive, sort of like a self-operating system. So it's my opinion that we've just sort of gone through this whole hype cycle relating to the metaverse, and the current sort of buzzy topic is AI. I think the next one that's coming is digital twins, and you're going to be hearing this term more and more. But just like those other things, you're going to be hearing it co-opted as a buzzword and maybe used inappropriately just to sort of generate eyeball traffic and things like that. So when you see a headline like this in the New York Times saying that a digital twin of the Titanic shows the shipwreck in stunning detail, you're now all smarter than that. This is not a digital twin. This is just a high-definition 3D scan, but it's not showing any of the systems and the foot traffic and the back of house operations and things like that. Digital twins can also do things like what we're seeing here. So this is something called 5D planning. So we have a 3D simulation here. But the fourth dimension is time, where we can actually now see construction develop and look at the sequencing of what aspects are being built when. And the fifth dimension, of course, is money. How much is this going to cost? And at what part during the construction process do we start paying for materials and sequencing these things? So we can now see all of these things visually integrated together to help with consensus building amongst all stakeholders. Rather than just interpreting a spreadsheet of a business plan, we can see the business plan in action and everybody can just sort of automatically understand what's happening by seeing it visually. Here's another example. This is a digital twin actually right here. This is a twin of the city of Orlando. Oh, that was supposed to be a video, excuse me. Yes, so this is a digital twin of the city of Orlando, and it is a live digital twin, so you can actually scrub through a timeline and see things like shifting demographic information, which can help influence city planning. This is a bridge in Norway, and a digital twin was not used in the planning, but it was actually retrofitted with a digital twin and sensor information, so that if something happens, if there's a fault, even somebody monitoring remotely or an automatic system can immediately see that there's an issue and shut down the bridge and save lives. One of the most common use cases of digital twins, again, is in factory and assembly. And this is where we can really see systems at work and analyze in an assembly line, how long it takes for an item to get to the next step in the process, and where the failure points are, and where the inefficiencies can be found. And if you look at this video and you sort of squint your eyes a little bit, it looks a little bit like a dark ride. And dark rides really kind of are like assembly lines or manufacturing plants. We're just taking guests and conveying them from one scene to the next. So that's what we do at World Buildr. And we create digital twins of attractions to integrate all of these different disciplines visually during the design and development process. This is an example of some of our work that we did for Warner Brothers World in Abu Dhabi for the attraction Batman Night Flight. This is a very complex integration process where we have these KUKA arms that are moving, and there are very specific sight lines necessary. And we have to coordinate when the media starts and when it ends, and where the audio is coming from, and the lighting, and directing the guest's vision and things like that. But in actuality, these projects become so big that there are all of these different vendors involved, and they're all very siloed and working separately from each other on their individual scope with the best of intentions, but then they get to the field and these very expensive mistakes happen. And anybody who's been on a big project like this, I think, knows exactly what I'm talking about. And here's one example on that attraction. This is a section view of one scene on that Batman attraction, where you see the KUKA arm that the guests ride on. That orange circular area represents the reach envelope, the safe area that guests can reach without touching any scenery or things like that. The green triangle represents the projector throw. And then you can see that curved screen there, which is what the guests are actually looking at, the media that the guests are looking at while they're on the ride. And these are all done by different vendors. And so it's this dance, because you want to get the KUKA arm pushed forward as close to the screen as possible, so that the media screen envelops the field of view. But at the same time, you don't want to cross into that projector throw, or else it will cast a shadow on the screen. And again, you have different companies doing different pieces of this one effect. So there's a lot of room for error, and coordinating things visually during the development while these designs are still iterating can save you a lot of time and money and mitigate a lot of risk. And in terms of what we do, digital twins are gaining a lot of recognition in architecture and construction and engineering. But what we do is a little different in that, yes, we have facilities, but we also introduce the concept of a timeline and a show and show control. What happens when is actually one of the most complicated things to figure out, sequencing all of these different effects and multimedia. And so a comparison I like to make is a player piano, or a piano roll, where you have a song playing back, and it's basically a bunch of holes that are punched in a script that are telling which keys to play which notes. And if you don't use a digital twin, it's kind of like saying, okay, this one vendor over here, we're going to give you keys 1 through 10, and then the next vendor, we're going to give you keys 11 through 20, and so on and so forth. And then I'm sure the whole song will come together fine and it'll sound great. That's a very risky way to do things, but risk has been a big part of, an accepted part of our business for too long. And digital twins, if you use them and you iterate within a digital twin, you can solve a lot of these problems. So again, this is the work that we do at World Buildr. Here you see this is a top-down view of a dark ride where we're playing around with things like dispatch interval and sight lines and lighting cues and media cues and on-ride audio cues and things like this. And with our software, you can actually pre-program a lot of these sequences into our simulation to figure out your timing and get all of your vendors coordinated and on board with the same idea before you break ground. And then you can actually, rather than play back the show virtually, you can actually then send the show control off board via DMX, OSC, and various show control protocols so that the simulation can then actually become the operating system itself and the show controller. You can also embed things like guest flow and throughput simulation. Now, this is obviously a very important part of our business. Another great example, this video looks like it's not playing, but you know, if you're on a ride on a vehicle and you find that you're seeing the vehicle in front of you and the vehicle behind you, that destroys the illusion. That's not good. So the solution there is to increase the dispatch interval, get the vehicles spread out further from each other. That fixes the sight line. But if your guest demand is the same, your line is going to get longer because your throughput drops. And so all of these things are connected like the organs in a human body. And so visualizing them together can save you a lot of pain later. This is another thing we did for drive-through experience during the pandemic, where this was sort of a complex show where we had to bring a bunch of cars in and park in one scene and then have a show scene play out and then move to another scene and park and have that show scene play out. And we had no idea how long each show scene actually needed to be. And lots of times that's figured out towards the end. You write a show, you have your director come and direct the actors and create the show. And then you realize, actually, this needs to be a lot shorter, and you cut a lot of content. But for this project, what we did was we actually started with their financial goals. Well, how much money do you want to make on this attraction? And therefore, what does your throughput need to be? How many cars do you need to get through per hour? And how long does it take for these cars to travel from one scene to the next? And we essentially reverse engineered what the ideal length of the show scenes needed to be to hit their financial targets. We're also doing things like pre-visualizing interactive experiences themselves, like an AR overlay for a museum exhibit. We're now taking a digital twin where we can simulate where these AR objects are placed in three-dimensional space. And are they spawning at the right rate? And are they spawning at the locations where guests can easily find them? We can use this for play testing and museum exhibits and things like that. And then, of course, this also means that these are hybrid experiences. We saw during this metaverse hype cycle that just happened, all of these brands and companies put all of this money into creating these custom metaverse experiences that were fairly static. There wasn't a lot to do, and the viewership was very low. So these brands were not really happy with their marketing spend on these metaverse experiences. But if you do your production, your design and development and production of your physical attraction this way, then you actually get a digital experience as a byproduct of the process at no additional cost. So now you can have one show controller simultaneously controlling a digital version and a physical version together. World Buildr does digital twins specifically for themed entertainment experiences. We're trying to add that idea of a programmable timeline into the larger concept of a digital twin, which is primarily for architecture, engineering, and construction. And digital twins are estimated to be a $48 billion industry by 2026 and a $78 billion industry by 2032. So this is the work that we're doing, and we are going to be releasing our open beta of our software in probably late March or early April. And some of the first people we're going to be reaching out to are university-themed entertainment programs. Have you guys work on it with group projects and test it and try and break it and tell us where the bugs are and that sort of thing. But this is a very exciting development, and I'm very pleased to share this with you. I believe digital twins are the future. So thank you for listening.